The tunnel worked perfectly. Two heads of state stood at its entrance and declared victory. The machines had done what engineers once called impossible. 38 kilometers of tunnel cut through chalk beneath the English Channel, connecting two nations for the first time in 10,000 years. The alignment error was measured in centimeters. The concrete held. The ventilation worked. The trains ran. And within 12 months, the company behind it could no longer pay its own interest. This is not a story about an engineering failure. The engineering succeeded completely. This is the story of a financial architecture so fragile that the moment the tunnel opened, the debt structure began to strain under its own assumptions. It had been built without a sovereign safety net. No government guarantees. The forecasts had to be right. The interest had to be serviced. The margin for error was almost zero. The numbers were supposed to work. They didn't. The idea of a tunnel beneath the English Channel is not new. Engineers had proposed it as far back as 1802. For nearly 2 centuries, the plan kept dying for the same reason. No government wanted to pay for it. By 1984, France and Britain had agreed something had to be done. Cross-channel traffic was growing. The ferries were congested. The logic of a fixed link was undeniable. What was not clear was who would bear the cost. The answer, when it came, was radical. No public money. None. The project would be financed entirely by private investors, built by a private consortium, operated by a private company. Governments would provide the concession, the legal right to operate, but not a single pound or franc of public funding. The tunnel would pay for itself. This was not an accident. The concession agreement signed in 1986 was explicit. Investors would carry the full risk. To raise the money, a company called Eurotunnel was formed. It went to the markets. It sold shares to banks across Europe, to institutions in Japan and the United States, and to 750,000 private individuals, ordinary people who believed the prospectus. Shares issued at £3.50 in December 1987 rose to £11 by mid-1989. The momentum felt unstoppable. The prospectus made 3 promises. The tunnel would cost £2.6 billion to build. It would open in 1993, and revenues would be strong enough to service the debt from the first year of operations. All 3 promises were wrong. Not slightly wrong. Catastrophically, structurally, irreversibly wrong. Construction began in December 1987. The machines went into the ground from both sides simultaneously. 6 from the English coast at Shakespeare Cliff, 5 from the French side at Sangatte. 11 tunnel boring machines, each weighing around 1,000 tons, each 11.8 meters in diameter, boring through chalk marl at depths of up to 45 meters below the seabed. Navigation systems kept the machines on course with a precision that seemed impossible at the scale involved. When the French and British teams finally broke through and shook hands in the service tunnel in December 1990, the alignment error was 36 centimeters horizontally and just 5 centimeters vertically. Over more than 30 miles of blind boring. But while the machines performed, the budget did not. Specifications changed. Safety requirements were upgraded. Air conditioning systems had to be added, not in the original design. The rolling stock, custom-built for a tunnel that had never existed before, proved far more complex and expensive than any estimate had accounted for. Construction inflation in southeast England was running at 21% per year, more than 4 times the rate the financial model had assumed. By 1989, with the tunnel still 4 years from completion, cost estimates had already ballooned to $13 billion. The 200 banks financing the project were warned. They kept lending because stopping meant losing everything already committed. The final construction cost settled at £4.65 billion in real terms, 80% over the original budget. Financing costs came in 140% over forecast. The tunnel was supposed to generate enough revenue in its first year to begin servicing its debt. Instead, in its first full year of operation, Eurotunnel posted a loss of £925 million. £925 million in a single year. The financial model had been built on two assumptions. First, that the tunnel would carry the passenger and freight volumes the forecasts projected. Second, that the ferry companies would retreat rather than compete. Both assumptions collapsed simultaneously. In the early years, Eurostar passenger numbers never came close to the projected 16 million per year. The actual figure bumped along at around 6 million. The freight tonnage forecast for 2003 was wrong by 40%. The reasons were multiple. The high-speed rail link connecting the tunnel to central London had not been built. Passengers arriving by Eurostar in the early years were delivered to Waterloo Station via slow, aging rail infrastructure. The journey from Paris to central London took far longer than the projections assumed. Meanwhile, the ferry companies did not die. They lowered prices. They increased crossings to 80 per day. They fought for every passenger and every truck with a price war that forced Eurotunnel to match their rates or lose market share it could not afford to lose. And then there were the budget airlines. The financial model had been built before Ryanair existed as a meaningful force, before EasyJet, before the era of £9 flights from Stansted to Paris. The entire Channel crossing market was smaller than forecast, partly because a competitor no one had modeled was pulling passengers out of the market entirely. Lower revenues meant less cash to service debt. Debt kept accruing interest whether the trains ran or not. By September 1995, just 16 months after opening, Eurotunnel suspended interest payments on £5.3 billion of junior debt. The daily interest bill had reached £2 million. The company could no longer pay it. £2 million a day in interest alone, on a tunnel that was running trains. The debt trap was slow. The 19th of November 1996 was sudden. At 21:48, a fire was spotted on heavy goods vehicle shuttle number 7539 as it entered the French portal. 31 passengers and 3 crew were on board. The driver was instructed to continue toward the UK, where the fire would be dealt with. When the locomotive lost power 19 kilometers into the tunnel, that plan ended. The fire burned for more than 13 hours. Temperatures in the tunnel reached 1,000 degrees Celsius. A 500-meter section of tunnel lining, 40 centimeters thick, was burned down to 2 centimeters in some places. The chalk marl behind it showed no sign of structural failure, but colliery arches had to be installed as a precaution. No one died. That alone was remarkable, but the commercial consequences were catastrophic for a company already leveraged to the limit. Freight shuttle services were canceled immediately and did not resume until June 1997. 6 months of zero freight revenue on the service the financial model had depended on most heavily. Eurotunnel's share price, already near historic lows, fell further. The company posted a loss of £642 million in 1996 before taxes. In October 1996, with the fire damage still being repaired, Eurotunnel completed an emergency debt-for-equity swap with 225 banks. The structure involved converting portions of the mountain of debt into ownership stakes, a restructuring described by one financial analyst at the time as one of the most complicated ever attempted. It bought time. It did not solve the problem. The interest never stopped accruing. The fire simply made certain that everyone could now see it. For the 750,000 ordinary shareholders who bought into Eurotunnel at the 1987 share offer, the arithmetic was brutal. Shares issued at £3.50 in December 1987 had soared to £11 by mid-1989, as construction momentum built and the prospectus projections still seemed plausible. Then the cost overruns hit. Revenue fell short. The debt crisis followed. Then the fire. By the time of the 1994 demonstration runs, when the tunnel was finally opening, shares had already hit an all-time low. The ribbon had been cut, the tunnel was working, and the investment was already approaching worthless. By the end of 1999, the net capital loss to an investor who had held their original shares was approximately 75%. £3.50 became 87 pence. And that was before the second restructuring. In 2006, a second full financial restructuring became unavoidable. The proposal put to shareholders would exchange the remaining debt, by then still £6.2 billion, for 87% of the company's equity. What this meant in practice was that the original shareholders, who had owned 100% of the company they had financed, would end up owning 13% of it. 13% of a company built with their money. On the 2nd of August 2006, a French court placed Groupe Eurotunnel into formal bankruptcy protection. 12 years after its triumphant opening, the company behind it was under bankruptcy protection. The shares that had sold at £3.50 were now effectively zero for anyone who had held through the restructuring. No dividend had ever been paid to the holders of original shares. Not one. There is a physical record of what this project cost, buried beneath the English Channel and left there permanently. When the tunnel boring machines completed the underwater drives in 1990 and 1991, the UK-side marine machines faced a problem with no clean solution. The tunnel lining had been installed directly behind each machine as it advanced, making the finished tunnel narrower than the machine that had bored it. There was no path back to the surface. The machines could not reverse. They could not be disassembled in place without compromising the new tunnel structure around them. So they were driven steeply downward, angled deliberately into the chalk below the tunnel floor, and sealed in permanently. They are still there. The UK marine tunnel boring machines, each weighing hundreds of tons and purpose-built for a project that would never be repeated, now serve a single remaining function. They act as electrical earth conductors for the tunnel's power systems, machines that cost millions to design and build, that represented the cutting edge of 1980s engineering, permanently entombed in chalk 45 meters below the seabed, wired into the electrical infrastructure of the tunnel they dug. One cutting head was preserved and placed on display outside the terminal at Folkestone. Another was sold on eBay in 2004 for £39,999. The rest are in the ground. It is a precise physical reminder. The cost of building the tunnel exceeded any calculation of what could reasonably be recovered. Not just financially, literally. The second restructuring was approved by shareholders in May 2007. Deutsche Bank, Goldman Sachs, and Citigroup agreed to provide £2.8 billion of long-term funding. The remaining debt was converted to equity. The original investors received 13% of the company they had built. That same year, the missing piece finally opened. High Speed 1, the rail link connecting the tunnel mouth to St. Pancras Station in central London, finally opened. It had been promised before the tunnel was built. It had been contracted in 1996. It took until 2007 to complete, 11 years late. The effect was immediate. Journey times from Paris to London dropped. Eurostar passenger numbers began to climb. Journey times fell. Passenger numbers climbed. And the revenue the original financial model had depended on finally began to arrive. 13 years late. Eurotunnel posted its first profit in 2007. 1 million euros. Barely measurable against the losses of the previous decade, which had totaled billions. But the direction had changed. By 2017, Eurotunnel, by then renamed GetLink, was generating operating profits above €500 million per year on revenues above 1 billion. By 2024, the group reported net profit of €317 million. The tunnel that one verified economic analysis concluded would have left Britain better off had it never been built, is now a profitable, functioning piece of critical infrastructure, carrying more than 20 million passengers a year. But here is what the recovery actually proves. The tunnel did not save itself. It was saved by a government rail line, built with public money, delivered 11 years late, that should have existed before the first train ever ran. The private model had always depended on public infrastructure. When it finally arrived, the numbers began to work. And they built it anyway. Just too late and too slowly to prevent the collapse of the company that had taken all the risk. The tunnel worked. The system built to fund it didn't. And the machines that dug it are still in the ground. Permanent evidence of what it costs when financial certainty is built on optimistic math. Subscribe for me. The next system is already in motion. Thank you.